Hello everyone. In this problem, you are given an array of integers. Now, one interpretation of this array of integers is that you can consider the ith element of the array as ith bag, and the value of that element is the number of balls in the bag. So, for example, 0th bag contains 3 balls, first bag contains 4 balls, second bag contains 5 balls, and third bag contains 4 balls. Now, what you're allowed to do is you are allowed to split an existing bag into two bags. Okay, you can split a bag into two. Okay, so you are allowed to split one into two. Now, after performing the splits, whatever will be the maximum value in the array, that is whatever will be the maximum number of balls in the bags will be your penalty. So for example, if I just start with the given array, what will be the penalty? The maximum value here is 5, so my penalty will be 5 in this case. Now I'm allowed to split the values, but I am given how many splits I am allowed. So let's say maximum number of splits. If I am given that maximum number of splits is 3, maximum number of splits is 3. So in that case, what I'll do is I will split 5. I will split 5 into, let's say, 3 and 2. Okay, this is one split I used. Then I'll go after the next largest element. Okay, so I will split 4 into, let's say, 2, 2, 4, and then, so this is split number 1 that I had. This is split number 2, and now split number 3 is three, then say 2, 2, 3, and we divide this 4 again into, let's say, 2 and 2. Okay, so now after the 3 splits that we were allowed, we could reduce the penalty. We could reduce the penalty. Okay, so this is split number 3, and after split number 3, we could reduce the penalty to 3. So penalty was reduced from 5 to 3 by splitting 3 times, or allowing 3 splits. Okay, now let's take another example. Let's say my array has only one element, 9, and I am allowed number of split operations to be 2. Now 9 I can split as 6 and 3, and then 6 I can split as 3 and 3. Okay, so the minimum penalty will be 3. Now the split can also go in a different way. You can say 9 will divide into 5 and 4. So 9 will divide into 5 and 4, and then the other split that I have, I can use on 5 or 4. So I'll use it on 5 because it's the larger one. So let's say I divide it into 3 and 2, and 4 remains as it is. So now what is the penalty? Penalty is 4, right? So even with two splits, if I split it the right way, I get the minimum penalty, otherwise the penalty is still higher. Okay. So I want to find the minimum penalty and I want to find the right split of the array as well. Okay. So let's say I have 8. Now my approach is the penalty values. The penalty values will be within a range. So for example, forget about number of splits allowed for a moment. Okay. Tell me what is the minimum penalty that can be obtained when 8 is the original element and you can split it. So you can split, the minimum penalty will be if you split 8 into all ones. So now you can go symmetrically and you can say you split it into 4 4, and then you split the 4 into 2 2, okay, and then you split all the 2's into ones. And then if you count the number of splits, how many splits are there? So this is 1, this is 2, this is 3, this is 4, 5, 6, 7. So in order to split 8 such that minimum penalty is 1, you needed 7 splits. Okay. Now in this case, no matter however you split 8, so even if you try this, if you try, let's say 8 goes to 7 and 1, very unsymmetric, then 7 goes to 6 1, and then 6 goes to 3 3, and then 3 goes to 2 1 2 1, and then 2 goes to 1 1. So even if you go that way, you will see that the number of um, splits is, this is 1, this is 2, this is 3, 4, 5, 6, and 7. So you still have 7 splits. So sometimes it doesn't matter, no matter how you try to split it, the number of splits will always be the same. My concern or my point here was that the minimum penalty for any element, let's say 8, minimum penalty will be 1. If you are allowed maximum number of splits, that is 7, then minimum penalty will be 1. So effectively what I'm saying is, if I'm given any element 8, I can have the penalty value, like if I leave it as it is, the penalty value will be 8, and if I split it, at the most I can go as low as 1. So I want to search for all possible penalty values that I can reach from the original array given a maximum number of splits. maximum number of operations, split operations is given to me. So given the maximum number of splits, what is the minimum penalty? So let's say I'm given that 8 is my array and the number of max split operations is, let's say, 2. So can I have 1 as a penalty? If I have 1 as a penalty, I have already seen that number of splits that I will need equal to 7, which is greater than 2, so it cannot be done. Can penalty be 2? Let's try. If I divide, okay, if I divide 8 into 4, this is 1 split, and then 4 I divide into 2, 2. But still this 4 remains the same over here. Okay, so therefore 2 cannot be the minimum penalty when, so I'll have to go one step further and divide it into 2, 2. So I'll need 1, 2 and 3 splits, right? So if penalty has to be 2, I will need 3 splits, which is greater than 2. Not possible. Penalty equal to 3. Well, 8 I can divide into 5, 3. Okay, 8 I can divide into 5, 3, and 5 I can divide into 3, 2. So yeah, penalty equal to 3 when, okay, penalty equal to 3 requires only 2 splits. So I can have maximum penalty as 3. Sorry, minimum penalty. I can have the penalty as 3 when maximum splits allowed are 2. Now, any penalty that I try after this, I can try 4. Penalty equal to 4. It will obviously be possible. 8 goes to 4, 4. 4 goes to 2, 2. Penalty 5 will be possible. 6 will be possible. 7. Okay, but I want the minimum value of penalty. So I will stop at 3. Minimum value of penalty that I got is 3. Now this is one approach. But we don't really know how far we'll have to go from the beginning. Now we started searching linearly from 1 because we want minimum penalty. So we started from the end of 1 and we saw, how many splits will be needed to get 1, how many splits will be needed to get the penalty as 2, how many splits will be needed to get the penalty as 3. Okay, so now we are going from 1, 2, 3 and so on. So this approach is called as linear search. What are we searching? We are searching for the minimum penalty value in this particular set of possible penalty values. Okay, 1, 2, 3, 4, 5, 6, 7 and 8. So this possible the set of possible minimum penalty values, this set is called as the solution space, or just the possible solutions, you can say at this point, possible solutions, and we are searching within the solutions. We are trying 1, we are trying 2, 3, 4, 5, 6, 7, 8. We are searching. So when we go linearly, it is called as linear search. Okay? We are linearly searching all the solution values, possible solution values starting from 1, 2, 3, and so on. Now there is a better approach. Okay. In this case, it required only three operation, it required only three elements to be searched. But sometimes, so what if for any given element, let's say we had to go till the end of the array or far away, far into the array. So it is not always the most efficient way. A more efficient search technique is binary search. So what will happen with binary search is, let's say I have my array 3, 4, 5, 4. What is the minimum penalty value? Minimum penalty value is always 1. Whatever array you are given, minimum penalty value that we'll consider will always be 1, and maximum penalty value will be 5, because the largest element is 5. Okay, so if we do 0 operations on this, we don't split anything, we'll get the penalty 5. And if we are allowed the maximum number of splits, we can split 3 into 1s, we can split 4 into 1s, we can split 5 into 1s, we can split 4 into 1s. So the number of splits that will be required in that case is, okay, so always if you want to split an element into all ones, you will need that element minus 1 number of splits. So you'll need 2 plus 3 plus 4, that is 9, plus 3, that is 12. So you'll need 12 splits in order to convert this array into array of all ones by splitting the element into two parts. Anyways, so 1 and 5 is the range of solutions I'm searching for. Now, in binary search, we always divide the array into two parts. So we first find what is the midpoint. The midpoint is higher value, so the maximum value here is 5. So 5 and the low value, that is 1, divided by 2. So 5 plus 1 divided by 2, we have 3 as the mid. Now is it possible, okay, I'll also establish here that, let's say the number of penalties, the number of maximum splits I am allowed here is, let's say, 3. Okay, so is it possible to have the minimum penalty as 3 when maximum splits are allowed is 3? Now if 3 has to be the minimum penalty, the first element 3 has no problem, 3 is the same as the minimum penalty. 4 will need a split, so let's say 3 and 1. 5 will need a split into 3 and 2, so number of splits are 2. And okay, so this is one split, this is another split, and 4 will need it to be split as 3 and 1. So yes, maximum splits 3. We can have minimum penalty as 3 when maximum splits allowed are 3. But can we do better? Better means we want minimum penalty. So can we go lower than this? To find that out, we now focus only on the lower part of our original range, lower half of our original range. So now 1 and 3 is the only part we are focusing on. We find the mid of this range. So mid is again high plus low divided by 2. So 3 plus 1 divided by 2, which is 2. So can we have 2 as the minimum penalty? Now as we have already seen here, okay, we can also start afresh if we want. Okay, so if the minimum penalty has to be 2, We cannot allow 3, we'll have to split 3 as 2, 1. We cannot allow 4, 4 will have to split as 2, 2. We cannot allow 5, we'll have to split it as, in fact, 2, 2, 3 will be one split, and then we'll again split. So let's say, okay, so we'll again split 3 into, this was one split, another split will be 2, 2, 1, and then last element is 4, which will divide into 2, 2. So one split for 3, one split for 4, one split for 4, and two splits for 5. 1 plus 1 plus 1 plus 2. 5 splits are required. So 2 cannot be allowed. So 2 cannot be allowed, so we'll have to focus on the upper half. Now, upper half here will be, so in this case, I'll just erase this. In this case, if you try to find the upper half, we have simply explored 3. If we go any higher than this, we have simply explored this. So our binary search ends here. Binary search ends because we increment 2 to 3 and the low, that is 3. So low becomes 3 and high is also 3. So there is nothing more left to search, and the answer we have found is 3. Answer we have found is 3. So this is the approach of binary search to search for the minimum penalty. Now for the same example, I'll show you the code. I'll show the output of the code first, then we'll discuss the code. Okay, so 3454, maximum number of operations allowed is 3.